The first 3 years of your life were filled with experiences, even though almost none of them remain in your conscious memory. You entered the world, opened your eyes for the very first time, and heard voices that quickly became familiar enough to make you feel safe. You took your first shaky steps, spoke your first word, and lived through countless moments that helped shape who you would become. Yet today, none of those memories can be consciously recalled. Not your first pain, not your first moment of happiness, not the first time you recognized someone's face and instinctively knew you were protected. Every one of those experiences truly happened, but they seem to have vanished without leaving behind a single conscious trace. Almost every complex mammal can access memories formed early in life. Humans are the remarkable exception during the very years that shaped them the most. Your brain didn't fail to store those early experiences because it lacked the ability. Instead, it intentionally removed them. And once you understand why, you're left with a question that science still can't answer completely. That smiling child in your old family photos really is you. But looking at those pictures can feel strangely unsettling. Someone might point to a photo and say, "You were so happy that day." Yet inside your mind, there's nothing. No image, no emotion, no faint echo of the moment. It's almost like staring at a photograph of a complete stranger who simply happens to share your face. The unsettling part isn't forgetting one specific day. It's realizing that an entire chapter of your life has disappeared from conscious memory. For years, the standard explanation sounded simple enough. People believed an infant's brain was just too immature to create lasting memories. The structures responsible for memory supposedly hadn't fully developed yet. Case closed. Except there's one major problem with that explanation. It isn't actually true. Back in 1980, researcher Carolyn Rovi Collier designed an experiment involving 2-month-old babies. She gently tied a ribbon from each baby's ankle to a mobile hanging above the crib. The babies quickly discovered that kicking their leg made the mobile move. After some time away, they were brought back. Even 2 weeks later, they immediately started kicking again as soon as they saw the same mobile. They remembered exactly how it worked. A 6-month-old infant can retain information for weeks. Clearly, the brain has no trouble forming memories during infancy. The real mystery is that something later removes those memories. This isn't simply the absence of memory. It's an active biological process that erases information that had already been stored. And the most surprising part is that this same mechanism is still working inside your brain today. It simply operates much more slowly now than it did when you were a baby. The hippocampus is the part of your brain responsible for transforming everyday experiences into long-term memories. In adults, this process happens gradually and in a highly organized way. In babies, however, the hippocampus operates at an astonishing pace. It produces thousands of brand new neurons every single week. Those new neurons don't simply get added to the existing network. They actively reshape the neural circuits that were already in place. Whenever a fresh neuron becomes part of a circuit, the existing connections have to be rearranged. As those pathways are reorganized, the memories that depended on their original structure begin to disappear. They aren't slowly fading with time. They're being actively overwritten by the brain itself. Your infant brain wasn't incapable of remembering. It was simply too busy rebuilding itself at an extraordinary speed. Imagine renovating an entire house while still living inside it. Every new room requires tearing down an old wall. That's essentially what your developing brain was doing. Each week of rapid growth came with a hidden price. The memories created just days earlier were sacrificed to make room for the brain's expanding architecture. But there's another piece of the puzzle that rarely gets discussed. Even if every one of those early memories had somehow survived, you still wouldn't be able to recall them today. That's because another, even more fundamental ingredient was still missing. To remember something as your own experience, you first need a sense of who you are. Newborn babies simply don't possess that yet. Scientists demonstrate this using a famous experiment known as the mirror test. A small colored mark is secretly placed on a child's forehead before they're shown a mirror. If they reach up and touch their own forehead, they recognize that the reflection belongs to them. Chimpanzees can do it. Dolphins can do it. Elephants can do it. Human babies usually don't pass the test until they're around 18 months old. Before that stage, there isn't yet a fully developed sense of self organizing their experiences. There is no inner narrator connecting one moment to the next. The emotions are absolutely real. The sensations are real too. But there's no personal story tying those experiences together as something that happened to me. Without that sense of self, there can be no autobiographical memory. It's physically impossible to remember events that were never encoded as your own experiences in the first place. The problem isn't that the file was lost. It's that there was never anyone there to file it. Take a moment to think about that. And by the time your inner narrator finally emerged, your brain had already become something fundamentally different from what it had been before. That leads to a fascinating question almost nobody stops to ask. If the child you once were had no real sense of self, and every part of that early mind has since been rebuilt, in what way are you truly the same person today? This isn't just a philosophical thought experiment. It's a genuine scientific question about the continuity of identity. And in 2014, two neuroscientists decided to investigate it in a way that completely changed the conversation. Researchers Sheena Jocelyn and Paul Frankland from Toronto's Hospital for Sick Children published findings in the journal Science that reshaped how scientists think about infant memory. These weren't fringe researchers making bold guesses. Frankland leads the hospital's neurobiology program. Jocelyn has spent decades studying how memories are created, stored, and eventually lost. What they discovered sounded almost unbelievable at first. When the researchers artificially slowed the production of new neurons in young mice, their earliest memories lasted much longer. But when they accelerated neuron growth in adult mice, recently formed memories disappeared far more quickly. Brain development and forgetting weren't two independent processes happening side by side. They turned out to be two sides of the exact same biological mechanism. The very system that built your brain also erased parts of what it had already recorded. This wasn't a flaw. It appears to be an intentional feature of how the brain develops. Even more remarkable, scientists found the same pattern across every culture they studied. No matter the country, no matter the language, people almost always have the same enormous gap in memory, covering roughly their first 2 or 3 years of life. Jocelyn and Franklin's explanation is supported by strong experimental evidence. Their model clearly explains why so many early memories disappear. But even their research couldn't answer every question. There was still one mystery left unsolved. And the clue that pushed scientists further came from a completely unexpected direction. Researcher Chi Wang at Cornell University compared people's earliest memories across different cultures. What she discovered shouldn't have been possible. if biology alone controlled childhood amnesia. In many Western families, parents regularly talk with their children about past experiences and encourage them to describe what happened. As a result, people's earliest memories often begin around 3.5 years of age. Among the Maori of New Zealand, where storytelling about personal history begins much earlier in childhood, first memories often reach back to around 2.5 years old. In several East Asian cultures, where early conversations focus less on individual experiences, first memories typically appear closer to age 4 or even later. That's a difference of nearly 18 months between cultures. Human brain development doesn't vary enough to explain such a large gap. So something else must also be influencing when our earliest memories become accessible. Before you learned language, your memories were little more than flashes of light, sensations, emotions, and raw experiences without names. Words act like containers that organize those experiences into memories you can later retrieve. Without language, those moments exist only briefly before fading away, like water poured onto the ground with nothing to hold it. That's why cultures that encourage storytelling at an earlier age often produce earlier childhood memories. It's not because children's brains develop differently. It's because the personal storyteller inside them begins forming sooner. So now we have two powerful explanations. One explains why early memories are erased. The other explains why some memories become accessible earlier than others. Yet neither theory can fully answer one final question. Think about your own earliest memory. It's probably not a random afternoon. It's usually not the event that happened most often, and it probably isn't even your most recent experience from early childhood. Instead, almost everyone's first memory carries something unique. It feels emotionally significant. Somehow, even in that moment, it already mattered. Scientists know that powerful emotions help strengthen memories, but that still doesn't explain why one particular moment survives while thousands of others disappear forever. The exact process that chooses which memory stays and which one is lost remains one of neuroscience's biggest unanswered questions. So was the baby in your childhood photos really a different person? Probably not. Research shows that certain personality traits can be traced from infancy all the way into adulthood. There is genuine continuity between who you were and who you are today. But at the same time, you aren't exactly the same person either. The neural networks that interpreted the world when you were 1 year old have long since been dismantled and rebuilt. The version of you reading this now didn't yet exist, and the memories that could have connected you to that earliest chapter of life were erased by the very process that allowed your mind to develop. In a very real sense, something had to disappear before the person you know today could emerge. Maybe that's why looking at old baby photos feels so strangely unsettling. Perhaps that feeling isn't caused by what's missing. Maybe it's the most honest answer your brain is capable of giving. While you were too young to remember your life, your brain was busy doing something far more important. It was building the person you would eventually become. And to make room for that person, it had to rewrite nearly everything that came before. In a way, you became yourself by letting go of the version of yourself that existed first. And if that child was already you, then your identity was built through constant reconstruction. But if that child wasn't truly the same person, then at some point you quietly became someone new. The most fascinating part is that you'll never remember exactly when that happened.